Okay, today in IM2 we're discussing chords, and this was the best picture of chords I could find on the internet, so I thought it was kind of cool since I like to draw too. Okay, so using chords of circles. Recall that a chord is a segment with endpoints on a circle. Okay, so anything with the endpoints on the circle. But if the chord includes the center of the circle, then it's called a diameter. A diameter divides a circle into two semicircles. Any other chord divides a circle into a minor arc and a major arc, which we've already talked about. Okay, so here are some chord theorems, very important to understand. In the same circle or in congruent circles. Now notice in a lot of circle theorems it says that. In the same circle or in congruent circles, two minor arcs are congruent if and only if the corresponding arcs are congruent. Now you could say the same thing about if in the same circle or in congruent circles you have two congruent minor arcs, then the chords that create them would also be congruent. Okay? The perpendicular chord bisector theorem. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay? Now, the perpendicular chord bisector converse is if one chord of a circle is a perpendicular bisector of another chord, so we can see that it's perpendicular and it bisects, then the first chord is a diameter. Alrighty. Okay, so they want you to use this information using a diameter, they want you to find HK. Okay, so the first thing that we're going to do is diameter JL, that's diameter JL, is perpendicular to HK. So by the perpendicular chord bisector theorem, this bisects this. So right away I know that this is 7. Okay, so HK is 14 because I have 7 plus 7 is 14. Then I want to find the measure of arc HK. So I know that 11x equals 70 plus x. So 10x equals 70. So x equals 7. So now be careful because that's not the measure of HK. We're going to find this one is 77 and this one is 77. So that tells us we found the right x. Then we have to add them. 2 times 77 is 154 degrees. And that is the measure of HK, minor arc HK. Alrighty? Okay, on this slide I put the reminder of what the congruent corresponding chord theorem is. These problems are on journal page 325. So we're going to use this theorem to solve for these measures. So the first one they're asking you to measure is WX, and I didn't use that theorem. I just said because of the vertical angle theorem, I know that this is 42 degrees. Since that's a central angle, then this is 42 degrees. So remember, you always have other tools in your toolbox that you can use. Don't be afraid to use them. Okay, be careful when you're solving. They're not asking for an arc here on number 2. They're asking for this segment right here. So since these arcs are the same because they both have the same central angle, then that means that the chords that they intersect are also congruent. So this would also be 3.6. Okay, then you look at WZ. Now both, if you look at this carefully, both WY and XZ are diameters. And both of the pieces of the triangle that encompass this are 180 minus 42, which is what you're going to do for the last problem. So once you realize that those are the same measure, these are going to be the same, okay, then that means that these chords that created them are also congruent. So since this one is 9.2, this one is 9.2. And the final one that they want you to do is arc XY, which is this arc here. And I just told you that all you would have to do is say 180 minus 42, and that is 138 degrees. So watch for those diameters. They are very helpful. Okay, so again, I've given you a reminder on this page of which theorem we're going to be using. So we have the perpendicular chord bisector. So let's put it to good use. So these are in your journal on page 325 as well. They want you to find the value of x. So we need to remember that when we have a diameter that bisects, that is perpendicular to a chord, that means it bisects the chord and it bisects the arc. So that means 2x minus 4.1 is this equal to x minus 0.5. And then we're going to add the x over, we get, or subtract the x, sorry, we get x. We're going to add the 4.1 equals 3.6. So is that what they asked me for? Yes, they asked me to find the value of x. Okay, over here, same thing. We have a diameter that is perpendicular to a chord. So we know that these two are the same. So 3x minus 5 equals 2x plus 1. Subtract 2x, we get x. Add 5 equals 6. If you want to go back and check each of these, so this is 12 plus 1 is 13. 18 minus 5 is also 13. So that one checks out. And you can make sure that you have the correct answer. Okay, another theorem we have is the equidistant chord theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So remember, when it says if and only if, then it would be if two chords are the same length from the center point, then the two chords are congruent if they are in the same circle or in congruent circles. So remember, this is what it's telling you. So look at that for a bit longer if you need to. So we're going to use the congruent chord theorem to solve this next one, which is kind of intense. So I want you to really work through this, okay? So here is our diagram. In the diagram, QR equals ST. So that's this chord equals this chord, okay? CU equals 2x. Look at the picture, that's the red number. CV, that's down here, is 5x minus 9. And they want you to find the radius. So think about, what do you know? So I know that CQ, which is right here, the green line, is a radius because it connects the center point, to a point on the outside of the circle, okay? We know that CU is perpendicular to QR because of the perpendicular sign, which means it bisects it. So those are equal, okay? Same, that's the only one. Okay, so now what we're going to do is we're going to go with that information. It says we're going to use, this tells us that this is a right triangle. This QUC right here is a right triangle. So now we're going to use those properties and the properties of chords to find the lengths of the legs and get the radius. Okay, so the first thing I want to do is I want to find CU. Okay, so I have to find what this 2x equals. So because QR and ST are congruent chords, we know that QR and ST are equidistant from C by the equidistant chord theorem. So CU right here is equal to CV. So now I can set those equal to each other. And I'm going to add the 9 over, and I'm going to subtract 2x, and I get 3x. So x equals 3, which means CU, and I'm going to erase some of this so it looks a little better, so we can see it a little bit better. So that means that CU equals 6. Okay, so then I'm going to plug this in, 15 minus 9, and this is also 6, so that proves that I got the right answer. Okay? All right, then the second step is to find QU. Okay, that is this segment right here. All right, so because the diameter WX is perpendicular to QR, we know that WX bisects QR by the perpendicular chord bisector theorem. So since we know that QR and ST are 16, that means that QU is 1/2 of 16, which means that QU equals 8. So this is 8. Okay? Now, we're going to find, number 3, we're going to find CQ, which is our radius. And how are we going to do that? So remember, back when we found out that we have a right triangle right here. So we're going to use the properties of the Pythagorean theorem here. We're going to say CU squared plus QU squared, we just found those, equals CQ squared. So CU was 6, don't go back and use X, use CU, 6 squared plus 8 squared equals CQ squared. So that's 36 plus 64 equals CQ squared. 100 equals CQ squared. So CQ equals 10. So our radius is 10 units. Okay? Everybody got that? So go back, push pause, or go back through the steps again if you want to hear that again. But those are the 3 steps that you do. So the cool thing that you're going to do is create a right triangle and then use the Pythagorean theorem. But I used other properties to find the other measures. Okay? So there you go. All right, so here's some more problems from your journal. And we're going to do the same thing again. So we want to find the radius. So the first thing that I know is that these are equal. Well, they already gave me those, so that's nice. We know that this CA is 5x minus 2, and DF is 3x plus 2. So right away I have to tell myself that I have to find what that measure is. Since these are the same distance from the center, they're both 3, I know that these chords are equal. So I can set 5x minus 2 equal 3x plus 2, subtract 3x from both sides. I get 2x. Add the 2 to the other side, equals 4. X equals 2. Now the main thing is don't use the x as your measure. Plug it back in. We get 10 minus 2 is 8, and 6 plus 2 is 8. So now we know we've got the right x. So what we're going to do now is we're going to find AB. And AB equals 4 because it's half of 8. Okay, remember it. The perpendicular line bisects our chord. So now we're going to make our little triangle, which would give us our radius. AP is our radius. And we're going to go 3 squared plus 4 squared equals AP squared. So that's 9 plus 16 equals AP squared. So 25 equals AP squared. So AP, my radius, is 5. Okay? So let's do this one more time. So for this one, they went backward, the opposite of what the last one was. They gave you the measurement of the chord, and they said the 2 chords are congruent. Because we know that the 2 chords are congruent, then we know that these 2 measures are equal to each other. So we're going to solve for what that measure is. So we can set them equal to each other. We get 3x equals 9, x equals 3. So make sure you check it. 12 minus 5 is 7. 3 plus 4 is 7. So I know that this one is 7. So I'm going to create my right triangle using my figures. YU is 10 because it's half of my bisected chord. So now I'm going to go 7 squared plus 10 squared equals OW squared. So I get 49 plus 100 equals OW squared. So OW, I'm going to go up here because I kind of ran out of room. OW equals the square root of 149, which is approximately 12.2. And that is your radius. Okay? So you should be able to do those kind of problems, work them through yourself, make sure you understand all the rules, And now here's a really interesting problem to see if you can solve it. Okay, so a neighbor gives you a plate of cookies as a housewarming present, and it's on her nice china. Before you eat a single cookie, the cat jumped on the kitchen counter and knocked the cookie plate to the floor, shattering it into many pieces. The cookie plate will need to be replaced and returned to the neighbor. Unfortunately, cookie plates come in various sizes, and you need to know the exact diameter of the broken plate. It would be impossible to reassemble all the broken pieces, but you've got one large chunk that has remained intact. So, how could you use this piece to figure out what size the plate is? So I want you to stop and think about it and see if you can figure that out. Okay, so here's what she needs to do. She could put this plate upside down on a piece of paper and trace this edge, okay? And then once she's got that edge drawn, she could draw 2 chords. Make sure she uses a ruler, and she would want to go actually where there is actual plate. You wouldn't want to go off the plate because that would be assuming something. So you'd make those 2 arcs somewhere on the circle that is left, okay? Then you're going to make a perpendicular bisector. So from here and here, you're going to do your arcs, and you're going to make a perpendicular bisector. Obviously mine aren't perfect, but we're going to fake it. Then from this point and this point, and we're going to do a perpendicular bisector, go through there, and this point here is the center of your plate. Now, since you're doing this on the paper, because that's more flat and more accurate, that point might even be over here, depending on how big that plate is. So, once you've got that center plate, she can measure from the center, wherever it is, to the side of the plate, and she gets the radius. Plates are sold by diameter. So then she could just double it, and she would know the diameter of the plate. And that is how she could replace the plate. Then she has to hope that it's not great-grandma's china and irreplaceable. Hopefully nobody would deliver cookies that way anyway. Alrighty. So that was a good thinking problem, and that should prepare you for your exit ticket. So make sure you look at what you're looking for. Sometimes you're looking for a measure of a segment. Sometimes you're looking for an arc. So be careful. And on number 2, you're finding the radius. So this would probably be number 1, number 2 on my questions, and this will be number 3, find the radius. So good luck.